We didn't look at it as a consumer device. Our initial reaction was, wow, wouldn't this be amazing as sort of an industrial device, as a portal through which people who are conducting commerce can ask questions about a complicated company or complicated organization and get immediate and relevant answers. Could you, in fact, take one of these Amazon Echoes? Presently, they're about $180, I want to say $160, $170, $180. That's relatively cheap. It's cheap enough to where you could deploy this technology on every desk in an office building or every conference room, let's say. So that begins to sort of get a little more exciting to us. So the question that we pose to ourselves is, could we take the Wolfram language, which we love and we know can help distill really complex problems and really complex systems, and can we sort of bolt that to the Amazon Echo in some way so that we're not interacting with models in the traditional way of sort of bringing it up on your computer and typing in some parameters or sliding some sliders and clicking some button and having some output, but rather we're speaking something, and whether that answer to that something is in the form of off-the-shelf data, fine. If it's in the form of a model, in other words, to answer the person asking the questions question, I have to go run a model and then return that back to them. The person asking the question doesn't care. They just want the answer to their question. So could we build a system like that? Because if we could, that opens up lots and lots of possibilities, which I'll talk about in a minute. So we took it on ourselves to do that. And again, this was before Todd Galey's work with his special package. So what I'm going to do is kind of take you through a little bit through the journey of how we went through that. So yeah, the basic idea is, yeah, sorry, that's so small. The rest of my slides are a little bit bigger, so you'll be able to see them. But essentially the idea is, can we do things verbally? So instead of typing, can we speak it? And even if we speak it impartially or improperly, can the system sort of still figure that out? So we get a lot of opportunities to watch people we build models for interact with these models. And again, it's an unnatural thing. So we might build a model, let's say, of a pricing formula. We did this not long ago. And it helped our client, who's in the retail business, price certain products. And it was a pretty complicated formula. It took into a lot of factors. And you plug in a lot of parameters and it says, okay, for this widget, that's $10.99. Okay, fine. So watching people interact with this model, well, first they had to find the model somewhere. It was on some server somewhere. Then they had to pull it up, and then they had to in fact, type in those parameters. They had to hit some button. It was a bit of an exhausting process. When we were in sort of a meeting with one of the people on the client side, and they said, well, why can't I want to know what should be the price of product X. I just want to know that. So why did he want to know that question? Well, because he had several questions about that whole class of products that were to be priced. So it got us thinking about, well, how do human beings, really want to interact with intelligent systems? Well, I'll tell you how. They don't do it unnaturally like I just described. It starts with this sort of broad general question. What is the nature of X? And then you get an answer to that question. And usually the answer to that question then inspires you to ask the next question. And then that answer inspires you to ask the next, and so on. So humans tend to follow a line of reasoning. So if we can figure out how to take the friction out of dealing with models by devices like the Amazon Echo, great. We might get to a point where not only are we building really intelligent systems, but we're doing something even better, which is making those intelligent systems a lot more accessible to people who just harbor some kind of question that they want answered, which, by the way, is the vast majority of people sort of outside this room. So this is a really important question for us, I think, because it is about how intelligent the solution is, but it's just as much about how you deliver that solution. So, along comes the Amazon Echo. And of course, the difference between the Amazon Echo and other similar devices, I mean, people talk about Siri and so forth, is its open architecture. It allows you, Todd mentioned these skills. Essentially, a skill is almost like extending the vocabulary of the device. So I could ask the device, I'll turn it off mute here for a minute, and I hope you can hear it. And I'll just ask some sort of random question. So, Alexa, what is 2 to the power of 32?
2 to the power of 32 is 4,294,967,296.
You already knew that answer, I'm sure. That's in its sort of base vocabulary, if you will. What you do is you add skills, and Jessie covered this a little bit in her talk this morning. You add skills to, a skill is essentially an app, or in our case, it's a model, or it's maybe as a series of models. So it's intelligent about this domain of something. You could make it intelligent about this domain of something by adding these skills, essentially adding to its vocabulary. So this was the notion that sort of guided us to our later experiment. So we had a company approach us, and this is an interesting company. They're in the barge business. So if you've ever been in a big river system, the Ohio River, Mississippi River, Tennessee River, et cetera, you see these big barges sort of move. This company had the highest market share of any inland barge company. So at any given moment, they've got thousands, maybe even hundreds of thousands of these barges sort of moving all over the United States. And they wanted to be able, they had this big data set. Every 15 seconds or so, they log what a given barge or vessel is doing. So they wanted to be able to ask questions of this data set. And they said, well, the current way that we ask questions of this data set is we have to go to this database or it's on some kind of obscure scorecard. It's just a really difficult and, again, friction-filled way to ask questions. We want to be able to ask questions in sort of a natural language way. So they handed us a sample of data. And the sample of data looked just like this. So it was literally an Excel spreadsheet. It was 30 megabytes in length. It was a 30-day window of all of their vessel movements. You can see that there's some vessel out there, and this event code might be it's docking, or it's refueling, or it's stopped for weather, or all those different kind of things that can happen to a barge from point A to point B. So we said, well, can we, in effect, curate? I'm using that term a little bit loosely. Can we curate this data in such a way that we can make it amenable to the Echo? So the first thing that we were confronted with was figuring out this whole Alexa ecosystem. It's not a simple endeavor. The Amazon Web Services is this enormous domain of various services that all connect together in various ways. Jessie mentioned the Lambda service. That's that sort of big block up there to the left. And there's Alexa voice services. There's something called an utterance. That's the actual speaking string. And then there's an intent, okay, based on what you uttered, what you really want. And so we had to learn all of this vocabulary, and I'm not here to kind of go over that vocabulary. I wasn't originally, but I'm really not, because Todd's now made that sort of all immaterial now, because you can actually go, kind of bypass a lot of this plumbing and go more directly, which is a great thing about Todd's work. But for us, it took us maybe a couple of months to sort of go through all this and figure out what was going on. Now, at the end of this long string, you see the Wolfram language. And in fact, we have our own instance of private cloud. And so we deployed functions because, and this is an important conversation, and there was a comment I think made earlier this morning about, well, what is you could have used Python in here, why Wolfram language in this? That's a very good question. And for us, I think the answer is it's really about computation. Yeah, sure. We could have used Python if we wanted to, but in terms of breaking down a question, I'd much rather have the computation horsepower of the Wolfram language than something like Python, which would have been, what, Jesse? Many, many other lines of code to do all of that. So. Not to mention the fact that, you know, there's another thought about bringing Wolfram alpha functions into the mix here that I think would be helpful. So, you know, I think having the Wolfram language there just sets us up to do a lot more things with it, and I'll go over some of those a little bit later. All right, so now let's do something sort of interesting here. You know, I've always admired Stephen doing sort of these live demos and taking the risk of doing that. So let's try to do that. Now, what I'm going to do, excuse me, I'm going to grab my little piece of paper script here so I make sure I read all these things correctly. You do have to be a little persnickety about how you interact with the echo. One of the things that we encountered is these little funny tips and tricks is it's not good with proper names. Bob, Mary, Sally. And of course, all these vessels had these proper names, and it like didn't know what we were talking about. Now, there are ways around that. I was talking with Todd. I think if you're building applications that use sort of proper names in this way, or non-English, cogent English terms, or whatever they call that, there are ways around that, but it was a tricky bit. So I'm gonna ask it a series of 3 questions. The first question I'm going to ask is you know, kind of the distance, the average distance between 2 locations, and I'm going to give them numbers instead of the proper names. Instead of, you know, like Little Rock to Baton Rouge, it kind of struggles with that. So I'm going to use names. I'm also going to ask about. I'm actually going to ask about a boat named Angelina and what it was doing on week 3. And I'm also going to ask about a certain location number, which is a port, on a particular day and what happened on that particular port. Now, the reason I'm telling you what I'm going to ask is because I want to ask these in succession, because one of the other things that we did with the Echo is we password protected it. So a lot of the companies that we talked to about this kind of capability have said, well, you know, what if the janitor is actually a Russian spy? They didn't really say that. And, you know, walks in and, you know, sort of asks all these questions, crazy questions about our company, and then sends that results to, you know, the mother country or something. We said, all right, well, fine. So we'll actually have a verbal password. The thing about the Echo 2 is that it does not distinguish voices. So it doesn't know me versus anybody else talking to it. So there's no sort of voice signature thing. But so it's an interesting question, yet unsolved by us, about, you know, what you do about security of these things if they're sort of hanging around in every sort of conference room and every office. So so it's password protected. So to keep me from having to enter my password every time I ask something, I'm going to ask them kind of in succession. So I'm going to tell you what I'm going to ask. I'm going to ask 3 questions, then I'm going to follow up with a 4th question here in a minute. So let's give it a whirl. See if it works. This Wi-Fi network has not been our friend this week, so everybody say a silent prayer that this is actually going to work. Alexa, port report.
Welcome to Business Laboratory Intel and Report. Please speak username and password.
George 230.
Name and password not recognized. Username, George. Password, 1230.
Yep. Try it again.
Please speak username and password.
George 230.
Welcome back, George. What report would you like?
Location number 9,940 and location number 2,247.
The average transit time between 9,940 and 2,247 is 15 hours and 23.0 minutes, and with a standard deviation of 38 hours and 23.0 minutes.
Angelina on week 3.
The vessel, Angelina, has 12 events for week 3 of March.
Location number 9,940, date March 3rd, 2016.
The location with identification, 9,940 had 137 events for month 3 and day 3.
Okay, so all that was from the data set that I just mentioned to you. So it was a fairly straightforward process to go from that data, and now it's able to sort of answer these questions.
I'm having trouble accessing your skill right now.
Goodbye. Okay. Now, so that was really interesting, and it was fun to do, and we were kind of surprised at how effective that was. I mean, she missed a lot of my verbal talks, but generally speaking, this is way better than Siri in terms of the voice accuracy. So we wanted to go just a little bit further here, and I'm going to try to leave room for questions. We wanted to see if we could do things to it visually and audibly. So this is something that Todd didn't do. So we're doing better than you. Which is getting a verbal response as well as a visual response to this. Some of the people that work at the company are big fans of Iron Man. They thought, oh, this is just cool. This is going to be just like Jarvis. So he said, well, all right, can this be done? So here we go. Oh, let me mute it for a second. Okay. Let me see if I can. Okay, I think that's going to be all right. All right, so this is a graph of vessel time at port. It's kind of doing a moving average and so forth. And so what I'm going to do is I'm going to ask for a different vessel, and it'll recalculate as I talk to it. So let's give this a try. Alexa, port report.
Welcome to Business Laboratory IntelliReport. Please speak username and password.
George 230.
Welcome back, George. What report would you like?
Compute vessel time at port.
The port report has been computed.
And there we go. Okay, so now we can, it's got hooks in here so that you can give it both a parallel audible response as well as a visual response. And I think that this is like a really powerful idea. So we're just getting started, but we're incredibly enthusiastic about all the different applications that are here. Jesse mentioned a few this morning. Corporations with an appliance on every desk. Wouldn't that be kind of an amazing capability if you're sitting here in Tesla and you could ask a question, well, what was our production yesterday, or what were our costs on X, and just get an immediate answer. So I've had a chance to talk to a few surgeon friends of mine, and I asked them, does it ever come up that you need information during surgery? And they said, this comes up all the time. And so they're painting this picture where you're doing surgery and you're cutting open Miss Smith, and you're looking inside and you notice a lesion on her small intestine, and you'd love to know, gee, have we ever had any patients with O-type blood, age thus and such, and have this condition? And you want something to say, oh, well, there have been 482 cases of this. That would be amazing. Right now, they have a human being at a computer in some of their more complex surgery doing this kind of thing. Sometimes they don't even have that, so they just have to sort of keep going. Wouldn't it be nice to have one of these devices where they could ask that? So we're having some conversations about that. Process plants and factories, anywhere where, gee, I want up to the minute sort of information. The other thing that's brought up about the Echo, and everything you sort of read and think about the Echo, is always this sort of, I'm going to ask a question and I get a response. But wouldn't it be nice if the thing actually talked to you without prompting? So what if you could say, Alexa, I don't want her to yell at me. I'm sorry? I did, yeah, because I don't want to respond when I say Alexa. Because I do that, when I talk about Alexa, she's, I didn't understand what you said. Which is the same response I get from my wife, so I don't know. But wouldn't it be nice if it sent you information without you prompting it with a question? So take the corporation metaphor. What if you could say, Alexa, anytime my competitor cuts their price by 5%, I want you to send me an email. Oh, by the way, I want you to run my revenue model and send it to my 5 vice presidents, or you know, something like that. I mean, that's a very legitimate thing to do, and then it would just follow that trigger in an if kind of way. We think that's nice. This thing is always listening, so if it's prompted by some information or some conversation in a meeting, wouldn't it be great if it offered some helpful observation about something that some topic that you were talking about? I mean, we're definitely sort of looking into this whole idea of push, and as I mentioned, sort of the if-like capability where I can verbalize, you know, if this, then that. How many of you have heard of this? Well, most of you. So it's a consumer app that basically allows you to build these recipes that sort of are triggered automatically. Well, that's awesome, but what if you wanted to just store a recipe that comes up in you know, as a topic in some meeting, and you turn to turn to Alexa and you create a recipe on the fly, and then she's also the channel through which that recipe gets triggered when some event of note happens. So we're obviously looking into that as well. So there's tons and tons and tons of applications. I think I went way over time, and I apologize. So I'll stop here, and I'll ask for any questions. Thank you very much.